Good evening, everyone, and thanks for joining us for another episode of vBrownBag. Tonight, I'm happy to present Kenny Garreau as he introduces Docker 101. And as always, we invite you to get in on the conversation. I'm going to be monitoring Twitter for the hashtag vBrownBag and also the Twitter handle at vBrownBag. The United States Wednesday night shows are not the only shows that we do. So if you are interested in joining us for the Latin America, European, or Asia Pacific shows, you can find the information in the schedule and sign up for the reminders at vbrownbag.com. I'm Tom Green, and I'm going to go ahead and hand it over to Kenny to say hello.
Great, thanks, Tom. Yeah, great to be back on the show. Did a whole bunch of episodes ages ago before I got married. But yeah, so hoping to fill everybody in on a little bit on Docker here. Pique your interest. We've got, I think, 3 more episodes for Docker after this one. So hopefully we give you a good foundational knowledge here and encourage folks to come back, next week and a few weeks after.
All right, I'll go ahead and give you presenter here, Kenny.
Great. Okay. You guys see my my presentation here? Everything showing good?
Yep. Looks great to me.
Yeah, so quick introduction. My name's Kenny Garreau. I live right outside of Boston, Massachusetts. It's my Twitter handle that you can find me at there. Trying to tweet more tech stuff, but you'll find a lot in there about football, soccer. I'm a VMware certified design expert, and I'm starting a new gig at App Dynamics. So yeah, just start to kick things off. Now, when John asked me to present here, he said, "Hey, look, can we do Docker from a virtualization guy's point of view?" And I said, "Yeah." So that's kind of the stance that I'm going to take here. Is if you're a hardcore app dev and you've been working with Docker for the last couple of years, a small mind like mine is not going to provide you with probably the knowledge that you're thirsting for. So really, we're trying to get the virtualization folks, our infrastructure admins, and then any technology generalists that are out there to learn a little bit about Docker and kind of get excited about what we're doing. So what are we going to try to cover today? Want to introduce you to containers. Want to talk to you a little bit about what the container architecture looks like. Talk a little bit about the problems that containers are trying to solve in the enterprise today. Also some of the challenges that they're going to introduce by going to that type of architecture. And then throughout this is going to be some hands-on showing you what we do with containers, and then pretty much how you can get started on your own, both from a learning perspective and from an actually running containers yourself. So let's do a little bit of a history lesson here. So we want to talk about who Docker is and what Docker is. So Docker started with a company called .cloud, which had a platform as a service offering, which was the Docker in its infancy. It evolved into the open source platform we now know as Docker. It's written in Go, so Google's programming language. It's open source software, so I can go out freely and download that and run it. So that's what we're going to be showing you guys what we're doing today. Now I already have Docker installed on my my instances that I'm running in AWS, so that's my miniature lab environment. But towards the tail end of the presentation, I'll talk about some other ways that we can run containers and get some learning done. Our main purpose in running a container is to run a singular workload or instance of an application within a Linux namespace. I mentioned Linux here just because That's my background. But if anybody doesn't know, Docker has gone public on Windows. That's one of the sessions that we'll be doing in a couple weeks here. Is firing up Docker on Windows and showing you how we do containers there. So, what the main purpose of these containers is from an infrastructure admin's point of view is that we want to reduce the overhead of running so many Windows and Linux virtual machines in our environment. And that could be virtual machines, it could be physical boxes. So the idea is that rather than me having one app tied to one operating system, instead I'm able to tie multiple apps to a single operating system. There's a larger Docker ecosystem that exists. Primarily one of the things you'll hear about is Docker Data Center. And that is really for us to figure out how do I manage all of these Docker containers that I have running in my infrastructure. I can create a swarm and I can manage services on the command line and manage my containers on the command line. But as we all know, that does not scale. We don't manage our vSphere servers. We don't manage our Hyper-V servers that way. We're not going to manage our containers that way. Docker Cloud. So I mentioned, AWS and Azure, I think, as places that we can run our containers. But for those that want to go directly to the source, Docker has a cloud offering available. And then, Docker Enterprise Edition, E exists for the folks that, hey, I love the open source movement, but I need to call somebody for support when this breaks or when my admins have issues or my developers have a question. So Enterprise Edition exists for the folks that say, hey, look, you know what? I want to run this and I also want support. And my support should not involve me debugging code or me, running out onto a website and Googling and trying to figure this out. So those that want support end up getting Docker Enterprise Edition. So who's using Docker? I'm not going to list out everybody because it's just a lot of people are running Docker. A lot of people are using containers out there. But what I would encourage you to do is go on a Docker's website, docker.com/customers, and take a look at some of the use cases that folks are using. There's been some very cool case studies that have been done around what people are doing with containers, how they've reduced overhead, their ROI, things like that, that you can then, that we traditionally did as virtualization guys. We had to sell that to the business. Hey, I want to invest in virtualization technology because this is what it's going to save us. Now, if you're the guy with the thinking cap at work and you go to your bosses or the powers that be and say, hey, you know what I did for you with virtualization? If you give me a little bit of budget, I can also do the same thing for you at the application layer. So why are people using these containers? What's the big deal around them? Primarily is portability. I can take a container, and if I build and architect that container is now portable between data centers, clouds. So if I have a Docker engine that runs in AWS and I have a Docker engine that's running locally in my data center, if I decide to publish that application to AWS, as part of my development process, and then I want to bring it in-house as part of moving that to production, I have the capability of doing that. And it's done in a very simple and very fast process. If I have task-oriented workloads, that's what Docker really excels at. I want to do one thing in a container and I want to do it well. And that kind of leads us into the next use case, which is microservices, which I can't spend too much time on in the presentation, but is something I'll touch on a little bit later. Microservices is not the only use case for Docker. There is no mutual exclusivity there. So if I'm doing microservices, it doesn't mean that I'm running Docker. And vice versa, if I'm running Docker, it doesn't mean that I've undertaken a microservices approach to how I'm doing things. Some of the considerations that I need to make are stateful versus stateless. And this could be in terms of the application. It could be in terms of my architecture. So the examples that I typically use are a database server versus a web server. Now, a database server has all my data in there, tables and rows, customer data, customer information, order history, all that good stuff that is important to me from a mining standpoint and a value standpoint. That's a workload that I would consider as being stateful. You know what I mean? When I move it, when I shut it down and I bring it back, I want that data to still be there. Now, if I look at a stateless type of application, so if I look at something like a web server, you know, that I might have a group of web servers that query that database. I'm not storing any data typically on that web server, so its life cycle in my environment is very different than that of, say, a database server. So those are the types of decisions that we get to make as architects to say, I might want to retain my, vanilla, SQL Server type of installation that I have, but I might want to containerize my web servers because, hey, they're all going to get the same configuration, they're all going to be behind the same load balancer, and nothing is going to be, very static in terms of, how those servers operate. And then the other thing that we'll stress is different life cycles. When I'm talking about life cycles, I'm talking about how long these entities actually survive on our systems. Again, since we're very task-oriented, many of my containers that I end up running, think of a batch job. So I used to work in financial services. We would have computers that would be dedicated to running batch jobs. Containerization is a way to replace those workstations that were running those batch jobs because they were running the same thing over and over for just a different customer or a different bank. Now, instead, what I have the capability of doing is containerizing that task that I want to repeat over and over and over and over, and instead I can use a container for that. I'm going to apologize for this ugly slide because I built this in Visio and then did not actually port this to a PDF or a PowerPoint friendly format, but hopefully I'll be able to illustrate well enough here. Oops. Just minimizing my my vBrownBag stuff here. So the traditional landscape of virtualization, I think, is something we're all familiar with, right? I want to virtualize the hardware layer. I want to provide an abstraction layer between my hardware and my operating systems that I run. VMware and Microsoft obviously are the two kings here, right? And VMware's, heads above Microsoft right now in terms of market share. So what I'm doing here is I'm saying, hey, look, you know what? I've got a single box, and what I want to do is I want to divvy that up. I want to create a set of virtual machines. They're going to 2 vCPUs. They're going to get 8 gigs of VRAM, and I'm going to give them each a 50 gig VMDK. So I split those resources up accordingly, and I do that in vCenter or SCVMM. I'm going to flip back and forth so you can kind of see the difference here between the slides as we transition. If we go back here, what are we typically doing? We virtualize one operating system, so let's say a Linux box, and then I install a Java application on there. Tomcat, let's say, is what we're using. In our containers, what we end up doing is we go a layer above. So now, instead of our abstraction layer being at the hardware layer with our hypervisor, so vSphere, what we're doing is we're providing an abstraction layer at the operating system a layer above. We'll get to the whole, this doesn't necessarily start to replace virtual machines. It's just a different way of doing things. That's something that we'll get to. So what we've done here is we've said, okay, now my abstraction layer becomes the operating system. And now I have the capability of running multiple applications on top of a singular operating system. That's the big difference between what we're doing with virtualization and what we're doing with containers. So rather than, so now what I get is, on a single host, I might run, 20 VMs. Now, instead of what I'm doing, let's take that same physical host. Instead of what I'm doing now is I'm saying, I'm going to install Linux on here, and now I'm going to run 20 instances of applications on top of here. So why? Why is that important? What's good about that? In the world that we live in from a virtualization standpoint, there's an extremely tight coupling between the virtual machine entity, my operating system that I'm running, and then my app and any customization that I am doing. So anybody that's gone through maintenance windows, that has done change control, knows this. Because what will happen one day is, Patch Wednesday comes along. I need to deploy Windows patches to 100 operating systems, let's say. Each of those guys gets patched individually, and each of my apps that are on there get rebooted. Now, as that starts to scale out, now what I start to see is that the layers that I have for my infrastructure are co-managed and interdependent, right? So when somebody says, hey, this weekend we're going to patch, this latest Windows vulnerability. And then the following weekend, the app owner says, hey, you know what? We're going to upgrade the code on Tomcat from 8.5 to 9.0. Well, those are two different maintenance events for the same type of workload. And they have very similar profiles in terms of their impact, right? I've got to alert the OS guys that we're doing, an upgrade. I've got to alert my customers that we're going to be doing an upgrade, things like that. When it comes to what I'm getting in terms of space savings or optimization, any sort of provisioning that gets done is thick, right? I know that, NFS obviously has thin provisioning, arrays have thin provisioning, vSphere has thin provisioning, but it's not really thin, right? I mean, because what I'm doing is I might be thin provisioning the data that comes on top of at this kind of customization layer, but everything that I get up to that point is thick provisioned. I need a certain amount of space for my operating system. I need a certain amount of space for the app that's going to run on there. And then my slice on the top is the customization that I have. It's the database that I load, or it's the configuration files for my web services. Any of the storage savings that I'm going to realize are going to be deduplication at the storage layer. So now we rely on kind of that, we're relying on our storage technologies to provide savings that we can now start to realize directly from our Docker engine. This introduces the concept of fault domains, right? If I've got an issue that hits a specific operating system, how does that affect me? What becomes my fault domain for these specific applications? Is it the operating system? Is it the application itself? Is it the infrastructure in front of the application? How do I plan for, minimizing the fault domains that I have? So namespaces within Linux are how we accomplish a lot of what we do within containers. So for those that aren't familiar with namespaces, it's a method for us to isolate and decouple pieces of the operating system from one another. This illustration kind of gives you an idea of what's happening. So at our operating system layer, we've got Linux, right? And let's just say, I'm an Ubuntu fan. So two things are kind of at work here in terms of how do I start to get down to brass tacks. One is this concept of a control group. Now, the control group's responsibility is to provide a certain level of resource to my namespace. This is typically in the form of CPU, memory, block I/O, things like that. So try to think of vCPU and reservations and stuff that we do within vSphere. In the namespace area, this is what I'm going to expose to the container or this namespace from kind of a file access layer. And that gets us down into how do I actually build that container and what do I present to it. So what you'll notice is that every container gets a PID1 because generally I'm running a container with a singular process. Each container gets its own network stack. Each container gets its own area of user space to use, and it gets its own set of mount points. So what I get here is separation between control groups and namespaces, And what I get there is I can have multiple PID1. So namespace 1 has a PID1, namespace 2 has a PID1, and they can't walk on each other. That's the responsibility of the control group in the namespace, is to segregate access between multiple entities. To know about, to kind of illustrate that, I think that the concept of images is really important. And it's important to understand what the distinction is between a Docker image and a Docker container. So when we think of containers, the container is a running instance of an image. So, think of it, in kind of bare terms as, the image is my VMDK, and the container is, after I've powered that virtual machine on, that is the running entity there. So the big benefit of Docker images is that we use layers. The layers are reusable. And as I start from the bottom up, my layers become read-only. So when I want to build an application, let's say, and this example that we're using here, I've got Ubuntu as kind of my distro that I'm using. I want to use Tomcat as my Java service to create my, to do my coding and to present my logic to my application. And then I've got that my Java app that I've built and constructed that lives on top of that guy. What we end up doing after that is creating a thin read-write layer when we instantiate that container. So what you'll find is in the image, I might create the My Java App image. And again, the My Java App image involves layers of Tomcat and Ubuntu underneath my primary, what I would consider my business layer, the My Java App. Each instance of this image, so each container that I decide to run with this, is going to have those three components involved. But when I spin these guys up, each of those guys reuses the layers underneath. And the only thing that gets written net new is this layer up here that we see. And I've got a better slide to illustrate this that's coming up. But really what this gives me the ability to do is to reuse these layers, and I can use one Ubuntu instance or one Tomcat instance in an image. Multiple images can use that. Multiple containers can then be deployed from those. And so you start to see kind of the space savings that we have. Not everything's going to be written in a single language, using a single app server and a single distribution. But if I've got 1,000 applications and 50 of them are Tomcat apps, I'm going to start to see some significant savings in my, in my infrastructure here. We get this via union mounts, and this is the slide that I'm talking about that's going to kind of illustrate this a little bit better. So kind of bear with me here as I kind of walk through this. What we're looking at here on the left-hand side is a Docker file. The Docker file defines what is going to happen with this specific image, right? It's going to define how we build the image, what layers are involved, what sort of settings I might put in at runtime. So what you can see here is we've got one line that says from Debbie and Jesse. So we are looking at the HTTPD package. So what the HTTPD package from Apache says is that, hey, look, you know what? When you start up HTTPD, you're going to use Debbie and Jesse as your kind of base OS. Our second line here sets a prefix, so just an environmental variable that we want to use as we're stepping through this Docker build file. The third line here says, hey, you know what? As part of this deployment process for HTTPD, you're going to create a directory for me. That's done here, right? So we're going to run, we're going to run this make dir command. It's going to create an Apache 2 directory. Clearly, there's going to be subdirectories that are going to get created under there. I didn't list them all out. You're going to have your conf directory, your bin directory. But let's just say you're just doing bin for now. If we want to illustrate the layers from a naming standpoint, We've got a Debian Jessie layer that's up here that is kind of the base that we've got. Oops, go the wrong way. We have an HTTPD layer that gets added on, that layers on that Apache 2 and that bin, file system that I've got there. And then I've got a writable layer. And you can see in this example here what I've done is I've said, hey, look, I'm gonna VI this httpd.conf file, and that's gonna be my customization for this specific container. Now, each container that we run maintains this small writable layer, right? And again, we want to design or think about the design of our applications as stateful versus stateless. So when we talked about that, we said, hey, look, you know what? I might have, a bunch of web servers, for example, and maybe I have a bunch of log data that's being ingested or being spit out by this web server. Maybe I want to hang on to that. Maybe I want to port that out to a SIM, or maybe I keep it in a local directory for a certain amount of time, or maybe I have a data retention policy that says, hey, look, you got to keep this data. Now, web server is probably less applicable than, say, what if I want to create a microservice and I want to use a database service like Postgres, and I want to keep that data. Volumes are a construct that Docker makes available to us to be able to present concrete data that maintains state. So I want to keep this data, right? If I go and create a container and I create this application and I make a new kick-ass web app and it's got a bunch of database calls that it's going to make, and I created a structure in the database, I don't want to blow away the database when I shut down the VM or when I shut down my container. So what we do here is we say, hey, look, you know what? Your container's running, and this is what kind of the file system layout looks like in the container. But then I also add in this data directory. So what's the benefit of that? Again, I want to store persistent data. Hey, I got a database here. This is going to be a Redis database, and I want to keep I want to keep all the data that I've got. I don't want it to go away when the container exits. Because again, that's the point here, right? When my container exits and I restart it, he doesn't have his old stuff there, right? If I've blown away that container and I bring him back, he's got nothing there that remembers that he was running 12 hours ago. I might want to share data between containers. So I usually give a couple of examples here. One, in the previous example of layers, think of linked clones, right, within vSphere. If I want to, deploy 800 virtual desktops, I might use a linked clone. And again, I get a thin writable layer, but I'm using that golden master image underneath to serve up all my desktops. And again, in this example, I have a data directory. So, user profile data, things like that I want to keep and that I want to retain. But when I shut down that VM, I don't want to lose it. That's the same concept that we're doing here, right? I want to retain a certain amount of data for a specific reason. The data gets shared between containers. So this is similar to the data store approach with vSphere, right? So I create a data store in vSphere, I present it to my cluster members, and everybody has access to it, right? So how does that help me, right? Well, instead of me having, if I've got 20 VMs on a host, I don't have 20 VMs making individual storage calls to a storage array, right? I've got 20 VMs that are making VMFS calls, and then the storage subsystem in vSphere then says, hey, look, all right, I'll take that request and I'll figure out what to do with it. So it's an aggregator. It bypasses the union file system, and it's independent of a Docker image. What that really means is that if I've got a volume attached to a container and I blow away the container, the volume data stays. I have to explicitly remove that volume for the data to go away. And now that goes to where that volume is going to live, right? So it could be a local destination. So I could put it, say, in a directory on a host. Most of us know that's probably not scalable. So what you'll see a lot of times being done with volumes is there'll be NFS mounts for my Docker container, for my Docker hosts. I can also create a volume container that I containerize, then I present the volume from that container to my other containers. So a little bit of an inception type of approach. But what we generally see a lot about there is, I've got 50 Docker hosts. They've each got an NFS connection to an NFS mount on a filer somewhere, a NetApp array, or a VNX data mover or something like that. And that's where we're going to push our data centrally. So let's talk a little bit about networking. When I go out and I deploy my Docker host, I get a few default options out of the box. And what I generally tell people is, you're going to get some stuff in vSphere. You're going to get your default, virtual standard switch that you're going to go and configure, and then you can add on other ones to give yourself specific types of networking. When we're talking about bridge networking, we're generally talking about, think of it as a NAT, right? So I'm going to get a network that all of my containers can connect to. That is the default network, by the way, that a container will get connected to when I instantiate a container. So if I do a Docker run and that container requires networking, it's going to get connected to the bridge network. If I specify host networking, what that means is that any services that I expose on a running container are now using the host networking stack. So if I start up an Apache Docker container on my host network, port 80 is going to be exposed on the host network stack. So not a typical deployment that we would see, generally like a testing type of scenario. There's also the none network, which is default. Basically, that just gives, the machine gets a network stack, but it's not connected to anything. So, you'll see a loopback device in there. Again, those are the three that get created by default. We also have the concept of user-defined networks. Now, the user-defined networks kind of take on two characteristics. One, I might create a user-defined bridge, meaning, hey, this is going to be a standalone Docker host on my network, but I want to customize a little bit outside of the default bridge, because maybe I've got a different IP scheme I want to use. Maybe I want to test out encryption between between workloads, things like that. Generally, what you're going to see most times, though, is the use of an overlay. And there's some not caveats, but there are some design considerations when you're using overlays. So there's swarm and non-swarm overlays. Really, what that just means is that if I'm not using swarm as my clustering technology, I might have a different type of overlay network that gets attached in a different way and tracked in a different way. So what I end up doing is I use this Docker network create. I use a specific driver, so you can see that on a user-defined bridge that I'm going to only be local networking for, meaning only to my host, is going to be using this bridge network. If I want to provide this network out to all of my swarm members or all of my cluster members, then this is the command that I'm going to use. And what that does is it informs the swarm that, hey, anybody that needs networking for the swarm and that requests it on here, this is the type of network that you're going to utilize. So there's a subtle difference between what we do with the networking here with an overlay versus, say, in the swarm versus what we do with the container. So the swarm, the cluster is responsible for cluster operations, right? Service registration, high availability, restarting of nodes, node placement, things like that. So what we do is when we create and we instantiate a service, that's what we end up connecting to the overlay. We don't connect a standalone container to the overlay. And I know that probably sounds a little bit confusing right now, but I think that when we go through the example, it'll make a little bit more sense. Really what we're saying is, hey, look, the swarm cluster is responsible for this overlay, right? He's the one that's in charge of this guy. I can't then just take a random container, spin them up, and try to connect it to that overlay, because how do I guarantee that I've got the right amount of resources? How do I guarantee that this workload should actually be running there? The swarm is what's responsible for kind of that federation. And again, that's part of that service registration. Dictates who gets my networking and who doesn't. So let's get to some pictures here, and I'm gonna hop into a terminal window here in a second to kind of show you what we're doing. So just want to illustrate this really quickly. What we've got here is our default bridge that gets created, so Docker 0. And then I say I want to run 3 containers. Say, hey, look, you know what? This is going to be a traditional web app database type of approach. So I say, hey, look, you know, I've got HTTPD, I've got a Node.js container, and I'm going to use Postgres as my database technology. So let's review what's happening. First, we start container 1. Now, keep in mind, there are flags that we can pass to this to specify what network we want to connect to. But again, remember we talked about if I don't specify any flags, this is the default network that we get connected to. And again, this is in standalone mode. We're not running in a swarm right now. Next, I start container 2. And then 2 things are happening with this command here that we've got on the left-hand side. 1, we are starting our container, our HTTPD container. We are then mapping ports from the host side to the container side. So what we're doing is we're saying, hey, by the way, we want to expose port 80 on the host to port 80 running in this container that we've got right here. We check out the networking using our Docker inspect command. So I'm going to hop out here real quick. Can you guys see my terminal window that we've got here?
Yep, shows up.
Okay. All right, I'm going to maximize this guy so you guys can see it much better. So let's clear this out. So what I've done here is I have logged into my Docker host. Anybody familiar with things probably knows that we're running on Amazon. So I have some Docker commands that are available to me when I log in on the command line here. I have some commands that are available to me when I'm running in swarm mode. And then I have some commands that are available to me when I'm running in standalone mode. So if I want to just say, hey, tell me what version we're running here, I get I get some information about what version we're running, what the API is, what's our architecture. Really what we want to focus on here is the capability of running and ensuring that our environment is running okay. So what the lovely folks at Docker have created a hello world package. So usually what I tell folks is when you're going to go deploy Docker, the first thing you want to do is run the hello world package. And what this does is it says, hey, look, you know what? As an entity, Docker is functioning just fine. What we've done is we've pulled down an instance or the image of the hello world image. We have now run it. I mean, we've run that container, and I can see my history here will tell me, what have I done here? And I can see that, hey, 20 seconds ago, I ran the hello world image. But when we're talking about networking, we want to say, hey, look, you know what? Why don't we show me what networks exist out here? So we can see here, hey, look, we've got the bridge network right here. If I want to run a workload and I want to attach it to that bridge, again, those are the commands that I want to run. So sudo docker run intd Postgres. If I don't give it a name, so I have 2 ways to kind of run this container. I can give it a friendly name, or what you can see here is Docker's kind of funny in the fact that it says, hey, look, you know what? I'm gonna give you a cool name like Inspiring Rosalind or Jolly Richie. So if I don't specify anything here, and I usually don't just because it does entertain me to see what they do come up with. So what I've done here is I've run this container. So when we get this GUID back here, we know that container is running. So if I do a Docker PS, I can see some information about that container. I can see the container ID. I know what image it's running. I can see the creation status. And then I can see if I have any ports that are exposed, this is where they get exposed. So if I want to do docker run itd node, now what's happening? Well, I never installed Node.js on here. So what's happening now is it's pulling down my images that are required. So all the layers that are required for this image, it decides to pull down from Docker Hub. We'll get into repositories a little bit later. But what this is doing for me is it's saying, hey, look, you know what? I noticed you didn't have it here. I'm going to pull down this application. And by the way, I'm going to run it after this. So you can see there, what we've just done is we're now running an instance of Node.js. And how long did that take? 20 seconds? Clearly, some of this is going to depend on how fast your internet connection is. But we just deployed an application in under a minute. So when folks say, you know, what's the big value about, you know, containers anyway? This is what we're talking about. This is what's so powerful about this, is that if I say, hey, look, you know what? I want to run another instance of Postgres, I can do that. Actually, I think it's gonna add a different one here. So I didn't run it detached. So now we see, if I do a Docker PS, is that I've got 2 Postgres images that are running out there. 2 Postgres containers are running for me. They both got different names, but they're both running out there. They both use the same, again, when we're talking about layers, they're using the same layers there, and I can continue to spawn more of these and more of these and more of these. You'll notice that when I didn't provide the options to run this detached, that it's going to put me to the standard input of that container. I have the ability to attach to the standard input of those containers. Now keep in mind, not all containers are created equal, right? So again, keep in mind that the commands that we're running here are probably our applications. If I decide to run a busy, sorry. If I decide to attach to this guy, now, what I get is a shell, right? So now I'm on the command line here, and I can hammer away with whatever it is that I want to do. This is my BusyBox instance. Clearly, I have an IP address on here. And what I can do here is I can do a Docker network ls, and I can do a Docker network inspect that bridge network, and I can see the instances and the containers that are attached here. I can see the IP addresses that I've been handed out. I can see information about my gateways. Not about my gateways, but about my gateway information's up here. Subnet mask, MAC addresses, things like that. So you notice, again, these guys all have unique MAC addresses. They all have unique IP addresses, but they're all on the same host. So let me go back here. I don't think I can Alt-tab here. So we got through our bridge networking. So let's illustrate a little bit how about overlay networking is different. So we assume a few things here. One, our images have been created and or downloaded or whatever. And our swarm cluster has been created. That's something I'll show you in a second here. But what I do after that is I create an overlay network. After my swarm's created, I need this. I typically need the swarm to create that overlay. Again, there's some non-swarm clustering technologies I can use, and then I can use overlays with that. But a lot of folks nowadays are using swarm clusters. So you can see here, we create that overlay network. And then what I do is 2 things. I create a service. So you see here, we're not doing a Docker run and giving it an image name, right? Instead, what we're doing is we're telling the swarm cluster to create a service. we're giving arguments of how many instances of that services do I want to run? What network do I want to attach it to? What do I want to name my tier? And this is generally a case where I encourage folks to use a name. Otherwise, when you're looking for specific things, it can get a little bit confusing. And then we tell the image that we want it to use. So in this instance, we're saying, hey, look, I want 4 copies of HTTPD to run within my infrastructure. I want to attach them to the overlay network. I want to call it my web tier, and I want it to use the HTTPD image. And again, we use our Docker network inspect command to find out what's going on with that overlay. So I'll bring this bad boy back up again. So if I do a Docker network ls, I actually already created this overlay network in here. So I cheated a little bit, but I can also say, hey, you know what? I could actually create more networks if I wanted to. I don't have to use just one overlay network. Now, where is that beneficial? That's beneficial from reducing my domain, my broadcast domain, but really, one of the major useful factors is Docker has native encryption available for our networks. So that's a very powerful tool set, but I might not want to encrypt absolutely everything, right? So in that scenario, what I might say is, hey, you know what? I want to create, let's say I'm governed by PCI. I might create a PCI network that I attach my PCI containers on that are carrying pin card data. And I might have a non-PCI overlay that I use as well for everything else. So just a quick example of something we might do. So what we can see here is we don't have any services that are running. So what I want to do is Docker service create, let's see here. And we will network will be Kenny's overlay. And I want to use the HTTPD image. So if we do a Docker service ls, what we're going to see here is what has happened now is I've created a service in Swarm. The Swarm service is called my web tier. You'll see the mode. The mode changes based on the status of my application, right? But replicated is all systems green. I have 4 replicas, which is what I had asked for, and the image that I'm using is HTTPD, the latest version. So if I am on this host, I do a sudo docker network inspect Kenny's overlay. What I will see here is some containers running here, right? So I will get information about the overlay. And then what we see here is Docker has actually said that 2 of the containers in my web tier are going to be running here. If I switch over to one of my other members of the swarm, and I say sudo docker network inspect Kenny overlay, I think I might have called it Kenny's overlay. What we see here is we've got 1 container running. So you'll see that, again, since I decided to run a number of containers that was not equal to the amount of members that I have in the swarm, again, it's going to start to distribute those in whatever fashion the swarm dictates. We're going to get into that in the next session about how we might want to change how we, distribute applications. So it's just kind of a quick taste about how we do networking, how networking, surfaces itself, how we run the workloads, and then, how they kind of interact together. So let me go back here. And let's see here. So we'll kind of go through this guy real quick. So when I get into container management, I'm concerned about a few things, right? How do I schedule workloads? So when we're thinking in vSphere terms, we've got our clusters handle HA and DRS. So high availability, and scheduling operations. So we want to think about, how do I get a platform that will help me schedule containers? I wouldn't manage vSphere, I wouldn't manage 200 hypervisors individually. I would use a centralized platform a la vCenter to do that. With containers, I have got a choice of those platforms that I end up using. And some of the ones that I'm listing here are just kind of examples, because there are quite a few that are out there. But these are some of the things that, when either if you're evaluating them or if you're interfacing with these guys, these are what these platforms are really responsible. So when I'm thinking about data management, I'm thinking about what is ephemeral, what is kind of ephemeral in my organization versus what is stuff that I want to keep. So we're talking about volume management, right? Hey, what volumes do I want to present to which services that are running in my infrastructure? Networking and security, I like the example we used before. Hey, look, you know what? These are PCI workloads, so I want to make sure that they're attached to, say, an encrypted overlay, things like that. When I think about how do I want to deploy new versions of applications, again, we're talking about something like continuous integration and continuous delivery. Again, they're not mutually exclusive. I don't have to have Docker to be doing this. And just because I'm doing CI/CD doesn't mean I'm doing Docker. So it's just another way for us to get to kind of, what our organization desires from a development and a deployment standpoint. And then finally, we're looking at monitoring. So how do I figure out what resources each of these containers are using? If I have some lower impact containers that I can maybe shrink their footprint on and pack them a little bit tighter. And then swarm management. Hey, look, I may not have one swarm in my infrastructure. I may have multiple swarms, just like we have multiple, clusters within our data centers within vSphere. And I apologize if you're a Hyper-V guy. Again, my background is obviously VMware, so most of the examples I'm going to use here are going to be based on vSphere. So registries are a very powerful tool, and I didn't really know where to place this in the presentation, so it kind of got after the management aspect. But when we're looking at registries, we're looking at, how do I get access to the applications that I either want to obtain or publish? So we've got this idea of public and private registries. So the biggest public registry that's out there is Docker Hub. There are other public registries that are out there. AWS has one, Azure has one. It's a way for me to push a package out or an application in a container image out to a repository and be able to fetch that later. This gets to the portability that we have available to us within Docker, right? I want to take this and I want to run it here, and then now I want to run it in Amazon. So again, Docker Hub is where I'm going to go and maybe get a copy of Ubuntu or Tomcat or Node or whatever the application is that I want to start to develop on. And then I get a choice of the versions that I want to use, right? So generally when I'm building an app, I might pull this stuff down from Docker Hub. But what happens if I'm not in the open source software business? What if I am a guy who's getting paid to develop an application or develop a SaaS platform? So the example that I used here is a university, right? So let's say I'm a university and I've containerized a couple of applications. So the first application is a student registry that I containerized, and the second is an online course registry. So you can see here that how I've kind of versioned things out. The student registry might be versioned one way, and then the online courses might be versioned in a more traditional fashion. But what I see here is 2.5.1, so clearly an earlier version of my application. I'm running Ubuntu, I'm running Tomcat, and Redis is my database for this. Now with the transition, say, to this new version of code that we've got in 3.03, let's say that I've decided, hey, look, you know what? I can get better performance and I can get some better scalability and features using Node as opposed to using Tomcat. Cool. What I have the capability of doing is two things. One, I can pull down that new image and I can run it, right? And I can port my data and off I go. I can kind of take the traditional approach of managing my applications. Alternatively, what I can do is if I'm running in a swarm and I'm running services and I say, hey, look, you know what? I want to take this service offline and I want to upgrade it to 303. Docker Swarm gives me the ability to upgrade those applications on the fly. And that includes that logic of moving from Tomcat to Node. Now, again, there's going to be some stuff that I've written on top of that, right? I can't just take an app written for Tomcat and shove it into Node and expect it to work flawlessly. There's stuff that I'm going to have to do to port my business logic from Tomcat to Node. So that's the stuff that's going to be contained in this layer here, the 303 layer, right? So when I say in my versioning that, hey, look, you know what? Swarm is running, 15 instances of the web servers for this application. If I want to go and upgrade that, I have the capability of doing that directly within the Swarm. So again, most customers are going to utilize multiple registries. They're going to have a public registry for the stuff that they want to pull down. You're going to use a private registry for stuff that, is making them money. So let's talk a little bit about how containers are being used. Guess where they're being used? So obviously in the cloud. That's the example that we've got here. My instances are in AWS, and I've created just bare instances of Ubuntu on the free tier. So again, one of the things we'll get to, great way to learn how to run Docker. But also many of the big guys out there, so Docker Cloud, AWS, Azure, have container services platforms that I can just go and I can natively run a container within that platform. So what's the advantage there? I don't need to maintain Docker. It's a big plus. Or I don't need to maintain whatever the container the container technology of choice ends up being. This is mainly focused on Docker, but there are other container technologies that are out there. 2, virtual environments. We got really good as virtualization guys to say to folks, hey, you know what? We virtualize first. You know what? That's our goal. We're virtualizing first. And by the way, you're not purchasing, Mr. App Guy, you, Mr. DBA, you don't get to purchase hardware directly. You got to come through us. And generally, we've been extremely successful with that. Most organizations are virtualization first. So for any of you that are, have app teams or development teams that you work with, you might be surprised if you went out and you asked them, you said, hey, look, A, are we running Docker anywhere? And B, where are you running it? Some of the app guys I know and the dev guys I know run it just straight on their laptops. But, a lot of folks do end up deploying production instances in virtual environments. That is a heavy use case. So a lot of you guys that might be watching this, you would be probably shocked, or maybe you're not shocked to find out that Docker's running within your infrastructure already. So what are we using it for? Core development operations. Hey, you know what? This app, hey, we're going to start using Docker to develop against. So I can pull down, I'm migrating this application to a new version, pull it down, and I'm going to start developing against the new version of Tomcat, for example. I can use it for application deployment. So again, we talked about that CI/CD workflow where I say, hey, look, you know what? I want to start deploying apps via containers. And again, I get flexibility and portability, right? I can deploy it the same way in Amazon that I deploy it in Azure, and the same way that I deploy it in my private data center. Same Docker run command. Software eval and testing, so kicking the tires on something. Hey, you know what? I want to see if, they said that the new version of Node is, 10x the performance of the old version. So I want to test that out. Or, hey, somebody told me that to try out this container in my environment to do some sort of ancillary task that I've been looking to do. Maybe I'll try that out. Microservices and enabling a microservices architecture. Again, just because you're going to go to a microservices architecture doesn't mean you're running Docker. And just because you're running Docker doesn't mean you're a microservices architecture. Again, they're not mutually exclusive. So they're not paired together or anything like that. But what you will find commonly is that when folks are looking at microservices architectures, they're also looking at ways to do that stuff like with a container with a unikernel. Migrating legacy applications. This is not maybe as prevalent a use case. Everybody's interested in cloud native apps and cloud scale applications, web scale, all that stuff. But let's say I'm a business and I've got 100 web servers out there. Some of them are running Perl, some of them are running PHP, some of them are running Python. Do I have the capability of containerizing them? Sure. Hey, if it's just a simple box that's, hey, maybe it's running a small database on it, and maybe it's just taking transactional data and passing it off to somewhere else. Sure, I have the ability to containerize that. Just running a simple if it's running simple PHP or Perl or Python or something like that, I can take that and I can say, hey, you know what? Let me build a container. Let me put Python on there. Let me put the appropriate Linux distribution that I want, and then I can port that application over to there. No problem. Now, obviously, there's testing and stuff that we've got to do with that, but when people say, "Oh no, I can't use legacy applications on Docker. That's a next gen thing, and we're not interested in that." That's not always the case. Short-lived services. So a lot of workloads that run in a containerized environment, are short-lived. When we think of short-lived, it could be a day, it could be a week, it could be a month. But typically it's not something that's living out there for an extremely long period of time. Most of the services that you run are going to run in a brief spurts of time. So again, the continuous integration, continuous development example, I might release code on Monday for an update to one part of my website. And then Wednesday rolls around and I want to push out another change. And then Thursday rolls out and I push out another change. I've now deployed 3 changes. That's not something I would typically do in a traditional environment, right? So what I may end up doing is I may say, hey, look, you know what? We're going to go to version 8.10 of the application on Wednesday, and we're going to version 8.11 on Thursday. And those might be different container images that I'm running. So again, it allows me to retain what was happening before in terms of coding and logic, and I'm simply moving to a new version of that service. So hopefully I've piqued your interest as far as some of the follow-up sessions that we're going to do here, and I hope everything's been as clear as I can make it. So for folks that want to get started with containers, I've been working with containers for about a year now, and I'm still learning. So we tell folks, hey, look, Amazon and Azure are 2 great resources because we can get some stuff for free. They're giving us the opportunity to learn about these technologies. So go out to AWS, go out to Azure, create an account, fire up some free instances, and try it out for yourself. The lab that I have here that's set up is all free. I haven't paid a dime for this, and it's been a great learning experience, a great learning platform. If you're a Raspberry Pi guy, I'm that guy too. I also have a cluster that's set up here, a swarm that's set up, running on a Raspberry Pi. So Docker runs on Raspberry Pi. Docker runs on Mac, Docker runs on Windows. So if you want to install it on your laptop, whatever blows your hair back, I think the message here is that the way that I would run that container in Amazon and the way that I would maybe run it on my Mac and maybe on my Raspberry Pi, probably going to be very similar, right? Same Docker run commands, probably the same images. There might be some subtle differences based on architectures, but generally we're going to see the same stuff running. We're getting into Docker on Windows and the capabilities of, can I run a Windows, can I run a Linux, container on Windows? Those are the things that we're going to kind of address in the Docker on Windows session that we're going to do a few weeks from now. I'll close with the resources that I commonly point folks to. One, the docs. Docker's docs are extremely, extremely well written. They are clear. They're concise. They've got pictures for guys like me. And there's an anticipated reading time. Hey, look, you pull up this networking information. It's going to take you about 15 minutes to get through this article. So you can kind of plan out your day and say, hey, look, I'm going to go get a coffee. I'm going to read this article. I'm going to come back, etc. Pluralsight. There are some. Nigel Poulton has put out some, and he's a Docker captain. That's one of the community things we'll talk about in a second here. Nigel Poulton has put out an excellent series on Docker on Pluralsight. So if you have a subscription, whether it's a personal subscription you have or whether it is through work, if you're fortunate enough for your work to pay for it, great. There are hours and hours of sessions there to learn a lot more than I'm going to be able to teach you in these 1 hour sessions. 3, participate. There are plenty of meetup groups around. Whether you are local to the US, whether you're international, whether you are in Boston or California or Denver or wherever you are, there's a meetup group near you. So check out the meetup groups. Don't be intimidated about going to these. Nobody's intimidated about going to a VMUG or a VTUG or anything like that. Go. These people are there to teach you. These people are there because they're excited and they're passionate about the technology. So you're going to see people there that are captains. You're going to see people there that have no idea what Docker is or are just tech newbies and just want to learn a new technology. So take advantage of those. And follow the folks that are out there that are Docker captains. Again, the Docker captains they're evangelists for Docker. They are the guys that are doing a lot of coding. They're talking about the product. They're very fluent in it. They're always very happy to help. So follow those guys on Twitter. Follow those guys, wherever you can. If there's a guy that's speaking to you at a meetup group, say, hey, look, I want to go there because I think this guy can teach me something. So I'm going to stop there. And I want to thank everybody for their time. I want to see if there's any questions, anything I can answer. If this was helpful, and anything that you might want to see in a follow-up session.
This was great, Ken. It was a ton of information, and even for a 101 course, it was a great deep dive into what really is going on there. As a VMware guy, I really got a lot out of that.
Great, appreciate it.
So I'm not seeing any questions come through, but while those are, do you want to go ahead and talk about what's next, looks like?
Yeah. So again, hopefully I haven't bored you guys too much. I know I spent a lot of time on the slides here. I wanted to get some time on the command line as well. I think that what you're going to see when we start doing stuff with storage and a little bit more deeper on security and networking and swarm, we're going to be on the command line a little bit more. So this was kind of to set the table, give you kind of a foundational view on what Docker is and what we're trying to do with Docker. So the next session is next week. We're going to talk a lot about Swarm. So again, there's going to be some overlap of storage concepts, network concepts, security concepts that are going to sneak their way into there, so we can give you some knowledge there. I will probably end up combining the storage, network, and security sessions, because I think that as folks have gone through the 101 we did tonight and the swarm session that we'll do next week, I think a lot of that stuff will be covered pretty well. I want to dive a little bit deeper on each of those. Spoiler alert, if you sign up for Pluralsight tomorrow and you go and you view Nigel's videos and you come back here, I'm going to look like a real dummy, because Nigel's a really smart dude. That's why he's a Docker captain. So again, if you want to stick with the vBrownBag, certainly stick with us. But the resources that are on Pluralsight are excellent. And the last session I think we're going to do is going to be Docker on Windows. I haven't got to play with Docker on Windows yet. Like I said, I'm pretty much a Linux guy, so I'm excited to deploy Windows, somewhere, probably on AWS, and create some Docker instances and kind of, go through that as a learning experience with you guys. So that demo might be a little bit bumpier, but hopefully we can learn something together.
That sounds great. It'll be awesome, and I know there's been a lot of talk and desire for SQL on Docker.
Yeah. There's a lot of use cases. I've got ASP.NET applications that I want to run on here. I've got SQL instances that I want to consider about Dockerizing, containerizing. That's been something that has been in kind of a tech preview for a little while. And now that it's mainstream, Microsoft is putting a lot of really good information out there, and there's a lot of MVPs that are out there that are also putting a lot of good information out there about Docker on Windows. So anybody that's going to DockerCon, I think the next one's in Copenhagen. Anybody that's going to DockerCon, I'm sure that you're going to find a lot of sessions around Docker on Windows.
We had a question that came in from when he says, "Is there any Google Cloud stuff?"
I haven't focused too much on GCP as far as what they're doing container-wise, so I would not be a good resource for that question. That's something I can take as a follow-up, though, and I can try to address that at the beginning of our next one with Swarm.
All right. Well, I think that'll do it for us for tonight. Everything's looking nice and containerized, so let's decompress, and next week we'll be back talking about high availability and Swarm.
Yeah, any questions that folks have, feel free to reach out to me on Twitter. I'm happy to help. And, if it's an answer I don't know, it's something I'm going to look forward to, figuring out the answer for you and for myself. So thanks to everybody for watching, and, we'll see you next week.
Yep. Thank you.